In section 4.1, I thought I'd start with number 19 for the videos and work some of these. And hopefully if you can watch these videos and you had trouble with earlier ones, you can now go back and figure those out. All right, I've got to distribute what's in front of the parentheses to everything. Now, if you have trouble with this, one thing you might do is put a 1 on this r here. When I have r1 and r1s squared times r squared, if you remember when I'm multiplying and I have variables with exponents, if it's the same variable, for instance, here we got an r1 and an r2, if you remember, we add the exponents. So this first term is going to be r of 1 plus 2, which is 3. It doesn't look much like a 3, but hopefully you're listening. And then you've got s squared. That's a 3, okay, on the r. All right, I'll do a different color for each term. Now I'm going to multiply this times this negative 2rs. A positive times a negative is a negative. So I'm going to just copy that down. And I'm going to say, okay, there's a 2 in this term. There's not a 2 over here at all, so I'll just, you can always think there's an invisible 1 here. 2 times 1 is 2, because that's really what's going on, right? But then on your r's, you've got 1r here and 1r here, and when you multiply them, you're going to add the exponents on the r. So 1 plus 1 is 2. I have r squared. And then I've got s's. I've got 2 s's out front, and then I've got another s here that I just put that little mark on to remind me that that's 1 s. So I'm going to write my s down. I'm going to add the exponents. 2 plus 1 is 3. Okay, then for the last term, I'm just going to say, okay, now we're going to multiply this. You could say, hey, there's no numbers on these, and so you don't write a number down. Or you could remember that there's a 1 in front of the s squared and a 1 in front of the rs, and 1 times 1 is 1, but we don't write it down because it's invisible, okay? So let's look at the sign then. A positive times a negative is a negative. And then I've got, if I look out here, I've got 1 r out front. I've got no r's here. So I'm going to write r. I could put the 1 on it, but I'm not going to because then I'd have to go clean it up, right? And then I've got s squared out front, but I got an s squared here. So if you remember what we do, we write the s down, and then we add the exponents. 2 plus 2 is 4. And there's our answer right there. Okay, you're going to have to ignore that line towards the bottom. It just happened because my hand hit the screen. All right, we are multiplying, and we have the same base. The base, remember, is the z part here. So I'm going to write the base down. And because I'm multiplying, the rule says I add exponents. Well, what are my exponents? Here I have n minus 2, and I'm going to add n minus 2 to the other exponent, n plus 2. Now I'm just going to simplify the exponents that I have. I've got an n and an n, that's a 2n. And then, so that took care of those two guys, right? And then minus 2 plus 2 is 0, but if it's 2n plus 0, that's just the same as 2n. So I'm just going to leave it, and I'm done. Okay, 23 is much like 21. You know what? It might help me. I'm going to come in here and I'm going to add some things in. I'm going to add in a 1 on this x right here. I wrote it in red so you can see that I added it. Now, I've got the same base. The base is, or the x part, right? It's the x, x, x. Okay, so x is my base. Now, when I'm multiplying and I have numbers with the same base, what I can do is add the exponents. So let's do that. My exponents are m minus 1, 1, and m. So we're going to say, okay, so m minus 1, and I'm going to add in the 1, and I'm going to add in the m because we add the exponents. Well, if you look what we've got now, write my base down, m and another m make 2m, and then don't minus 1 plus 1 add up to 0. I could write 2m plus 0, but that's just the same thing as 2m. So remember, we don't write things that Lazy Math Guy wouldn't write. They're there, and sometimes I point them out to help your understanding of what's going on, but we don't write them if we don't have to have them, and that way, it's proper communication in math. Okay, 27 it's an optional problem, but it's very doable, so I want to go ahead and go through it. I'm going to go ahead, and I notice that I've got a t out front, and I got all these bases of t here. Let me go ahead and put an exponent on there, because I know I'm going to distribute that t, and when you distribute, aren't you multiplying? So I'm going to write these out a little bit, each one, just to kind of help maybe help you get through it a little bit better. I'm going to put each one a different color, okay? So I've got t to the 1 times this t to the n minus 1. I'm going to go ahead and do all this distributing first, then we'll clean up, okay? Now I see a plus sign, so now I'm going to distribute this t times this t to the n. And when I do that, I've got the common base of t, so I write it down, and then I add the exponents 1 plus n or n plus 1. I'm just going to write n plus 1. Just put the variable first. And then now I'm going to distribute t to the 1 times this last term down here, t to the n plus 1. So again, it's a positive times a positive, so I'll write a plus down. I've got the same base of t on both of them, so I write it down, and then I'm supposed to add the exponents. Well, I have an exponent of 1, and I have an exponent of n plus 1, so it's 1 plus n plus 1, and all that's an exponent. All right, now let's do some cleanup. Looking at the blue term, okay? I'm still multiplying two things, right? I haven't added anything together yet. I wrote the exponents to add them together, but I didn't actually add them, okay? If you look at this first one, t to the 1 times t to the n minus 1, I'm going to write down the t, and I'm going to add the 1 plus the n minus 1. Now let's go ahead and simplify that, because 1 minus 1 is 0, or they cancel out, and I get t to the n for the blue term. Let's go to the green term. You put the plus in between each of these. That's t to the n plus 1. Can't do much more with it than what's already there. Okay, let's go to the last term. Now I have t to the 1 plus n plus 2. That would be t to the, if I add the 1 and 1 together, I'd get n plus 2. So we've got t to the n plus 2. Now, on 27, there's nothing else you can do to simplify that, because you can't, there's no rule that says when you're adding some things that have exponents, same base but different exponents, that you can add them together. For instance, just as an example of what I mean, if I have x squared plus x cubed plus x to the 4th, I can't add those together, can I? So we're done when we get here, and that was the challenge problem.